Okay, let's tackle question number 7 now. And boy, question number 7 is starting to get into talking about something called significant figures. And this topic is described on page 28 through probably 31 or 32 of your textbook. If you struggle with this, it's probably a great idea to read over that section of your textbook because from time to time, we will need to know the rules for significant figures, not only how to count how many are present in a value, but also how to use rules for multiplication and division and addition and subtraction. That's all outlined in that section of your book. So it's really good to kind of review over that material if you have not seen this before or you need to brush up on what we're about to talk about. There'll be some follow-up problems later that actually apply the rules, but now we're just going to count sig figs. So the question that you're faced with here in 7 is you're asked which of these measurements is expressed to 4 significant figures, and you're given a series of choices, okay? And you're basically asked which one has 4 sig figs, as we call it, or significant figures. And these significant figures, or sig figs, are basically the way that measurement scientists keep track of precision. And when we report a result, we don't want to over-report precision to give a false sense of how well we have measured a number. We also don't want to under-report precision. That would basically throw away digits that we have measured, and neither one of those are optimal. So we track our significant figures to be sure that the answers that we report specify the correct precision in terms of how well we know the number that we're reporting. Sometimes we know the value very, very precisely, very exactly. And in other cases, we don't. And sig figs is just a way to track that, okay? Now, there are some rules for determining whether or not digits in a reported number are significant or not. The first rule is really easy. This is my favorite. Any number which is not 0 is always a significant figure. That's easy, right? If it's any other number besides 0, it is significant. It has been measured, we'll say. But zeros in numbers are always much more tricky. So when do zeros count as sig figs, and when don't they? They essentially count if they've essentially been measured, oftentimes you hear, and they're not placeholders, okay? So zeros do count if a decimal point is present in the number and the 0 is written to the right of another non-zero number. Both of those things are true. Our zeros will count as significant figures. Now, on the other hand, sometimes zeros do not count as significant figures. If a 0 is a placeholder, it does not count. So consider this number right here. This number will have only 3 significant figures. Those are the ones shown in black, these last 3, the non-zero ones, okay? All of the zeros are considered non-significant there. All the red zeros, not significant. They're just placeholder zeros. Now they do appear to the right, or at least 4 of them appear to the right of a decimal point. However, they do not appear to both the right of the decimal point and a non-zero number. So because of that, those red zeros are not significant, okay? Zeros also don't count. If a decimal point is not written, zeros are not significant unless the zeros are presented in scientific notation format. If you actually write the zeros in a scientific notation format, that indicates then that they are to be considered significant. All right, so these are the rules. They're kind of confusing in a way. So sometimes it's good to work examples, and that's why I'm going through this video with you all and introducing to you to this concept, reviewing this concept with you, is to get this down, okay? Because this is students oftentimes find this a little bit annoying, and I completely get that. But at the same time, there's homework questions on it. There's perhaps going to be test questions on it in some way, shape, or form, and we want to make sure that we've mastered those rules so we can get credit for what we know, right? All right, so which of these measurements are expressed to 4 significant figures? And I'm just going to kind of highlight what I think is a pretty good answer. And then we're going to go through and explain why that is indeed the answer. Okay, so I'm looking at choice B right here, 62.4. Boy, I think that's a pretty good choice. Now, why is that a good choice, and why are the other ones not good choices? Okay, well, let's go through them. 1300 Kelvin. Kelvin's a temperature measurement. You probably already know that, but this is 1300 K. So let's assess how many sig figs this has. So I look at that, and I quickly figure out it's got 2. The only digits which are significant in that number are the non-zero ones. Those 2, the 1 and the 3. Those are the sig figs. The zeros here are not significant because they do not appear to the right of a non-zero number, and the decimal point needs to be there. Okay? Now, I can make life even more complicated for us here if I want to. Boy, what if I did something different? This is going to throw you for a loop, right? You're not familiar with this. What if I write 1300 period Kelvin, or dot decimal place? Turns out then there are 4 sig figs. All of them are significant. And all I did is I put that decimal point there. Okay? All I did is put that decimal point there, and that makes those zeros significant. Now that could be a good answer if the decimal point was there, but you know what? There's no decimal point there, so that's not right. There's only 2 sig figs. Okay? All right, so let's look at choice C. So choice C is 0.423 kilograms. Now there are 4 digits there, and 3 of them are obviously not 0, so there's at least 3 sig figs. So the question is then, what about this leading 0? Is that significant or not? Let's think about it. For the 0 to count, the decimal point must be present, and the 0 which is present has to be written to the right of some other non-zero number. Now the problem is this is to the left of the non-zero numbers. So that one is not significant. And as a result, this value has 3 sig figs. So that one doesn't work as an answer either. 3 sig figs. What about 82,306 meters? Key in on the non-zero numbers first. And there are at least 4 sig figs in this number. Okay, but what about the 0 right there? Turns out if zeros appear between non-zero numbers, they are significant. So that 0 is significant. It's been measured. So it is significant. So in fact, there's not 4 here, but there are 5 sig figs in this value. So that can't be right. And the last number is the only one that's left. So if a 0 appears between other non-zero numbers, any 0 appearing between non-zero numbers is also significant. It is significant. And the only one that's left is 24.049 centimeters. This is a similar situation. We've got 4 non-zero numbers with a 0 sandwiched in between. You guessed it, that 0 is significant. And this has 5 sig figs. So that's not a right response. It doesn't have 4 because we would need to find the one with 4. So the only answer, which has 4 sig figs, is choice B. And you ask, what about that trailing 0, right? Because if you look at the number itself, it's 62.40 grams. Well, clearly, the 6, the 2, the 4, that gets us to 3 sig figs. But we think, what about this 0? Well, that 0 is to the right of a decimal point. It is also to the right of a measured non-zero number. So that 0 is significant. It is significant. Right? It is a sig fig, which means that 62.4 has 4. That is our answer to this question.